Hello, everyone, and welcome to the fourth day of LightCon Preview Week. My name is Janina Lohle, and I'm the project manager of LightCon at Deutsche Messe. And in the Deutsche Messe, I'm very happy to welcome all of you today to this webinar. LightCon is our new International Congress trade fair for all user industries and the first cross-material and cross-technology platform for lightweight solutions. And if everything would have gone as planned, we would have finished our premiere last night. Unfortunately, due to the current situation surrounding the coronavirus, we had to postpone to next year, June, sorry. Nevertheless, I'm very glad that we are able to still meet virtually this week and present you with a little preview of LightCon 2021. We are glad to see so many interested viewers. I think we have about 70 people already here at the moment. And to all of you, of course, a very big welcome and thank you for being here with us. A special thanks goes out, of course, to our speaker of today's lecture, Mrs. Brickwede, who will share some insights with you today. And last but not least, I would like to thank our founding partner, Composites United, for the great cooperation and the support in organizing this event. That's it. Please join today's webinar of LightCon Preview Week, and I give the screen to Bastian Brenken.
Good morning, everyone. Also, on behalf of Composites United, a warm welcome. We're excited to have our next great webinar today lined up for you. But before we start, I will briefly explain the structure of today's webinar in case you weren't with us yet this week. So the first 30 minutes, Ms. Brickwede will have the floor, and she will explain to you some exciting new novelties in the area of additive manufacturing. And then the second half, you will have the chance to ask a question and make a comment or a remark. And for that, we will use the raise your hand function in Zoom. But I will explain this when we get there. The first 30 minutes will be for Ms. Brickwede only. Please, at all times, leave your camera turned off so that Ms. Brickwede is not disturbed by any persons appearing on her screen. With that, I thank you very much for being here today, and I leave the floor now for Ms. Brickwede, who is the Managing Director of Mobility Goes Additive and a very, very popular speaker these days. So I'm very, very glad that she was able to make time and that she's here with us today. The stage is yours.
Thank you so much, Bastian. I'm really glad that I can be with you today, although I would have preferred Hanover, of course, but this gives us a perfect opportunity to meet at least virtually. So I would like to give you a brief introduction into additive manufacturing, which is currently more known under 3D printing. And 3D printing is the technology to have this lightweight opportunity for different kinds of production for different sectors. And today I would like to give you an overview about additive manufacturing in rail, in automotive, and also some other sectors, and medical. So are we going to be cyborgs in future? That is also one question I would like to touch today. So if we take a closer look at different studies, there's a very interesting one, which comes from the Dutch ING Bank. That was published 2 years ago, and it says that by the year 2040, 50% of every part worldwide, all the parts will be printable, no matter what. If you just imagine what that means, 50% of all parts worldwide will be printable. That has a huge impact on many, many sectors and industries. And we are at the very start of that technology still, although it's nearly 30 years old. And there is not the 3D printing technology. It consists of more than 20 different technologies for different materials, different structures. And I would like to give you a short overview now. So what you can see here are the most common ones which are used, for instance, in mobility. you have the FDM technology. That is what you for sure will know. You might have seen that. Those are also the desktop printers which can print plastic parts made from a plastic cable which is heated. You always, in all those technologies, have a layer by layer structure. So you can produce things absolutely differently to former technologies, like, for instance, casting. And what you can see here are just some examples, but it gives you a very big freedom of design. What you can see next to it, the PBF, is the abbreviation for Powderbed Fusion. That's a technology which is used with powders, what the name already says. And there you can see it. You have a very thin layer. It's just 1 hair thickness thick. That is sintered by lasers. And you can use different kind of powders. That could be plastic powders, but it also could be metal powders. What you can achieve is a very good structure and very high density of parts, and also very good surface. What you can see with the MJF abbreviation is the multi-jet fusion. That's a technology which was invented a couple of years ago by HP. The logic is a bit like the 2D printing, and there you also use powders, but no lasers. So it's much cheaper, and it's also much faster. And the things you can produce with that technology are by now mainly plastic parts, but they are also working on metal parts. You have 2 different liquids which are brought into the powder, which you can see right now. And those liquids are also hardened with a special kind of light. And then you see the DED technology, that's the direct energy deposition. And that can be used for huge metal parts. That is a technology which is not too old. It's just a couple of years old, but very, very interesting when it comes to big metal parts. Because if you want to print those huge metal parts in the powder bed technology, it will take you a very, very long time, and it will be quite expensive. So DED, you use a metal wire, and you use an arc, and with that the part is melted, which you can see over here. The surfaces are very rough, so you have to post treat it definitely. So coming to the next slide. Here you can see the principle of what you can do. So to think additive with this additive design, here's the difference coming from an original design. This is just an example of certain grippers. And then you can reduce the part. Yeah, you can reduce it by size, by material, and you can even optimize it. So afterwards, with the generative design, which is the 3D printing design, you don't have any assembling anymore, which saves a lot of costs and maintenance and assembling, of course. So next slide. If you take a closer look at those technologies, it's really interesting that the industrial part of additive manufacturing is mainly located in Europe. So you will have a lot of brilliant desktop printers coming from the United States and also other countries. But if it comes to industrial printers, that's mainly Europe. And here we are really specialized on approved parts, which means highly regulated sectors use additive manufacturing already, sometimes even for a very long time. For instance, the aviation industry. The aviation industry uses additive manufacturing to save weight. They have a very simple logic. If they can save 1 kilogram during a life cycle of 25 years of an average plane, they save 10,000 euros. So you can take a look at the costs of additive manufacturing, which are usually definitely higher than the former technologies. but in that case, it really makes sense. And lightweight is the task for aviation in AM. The shipping industry uses also additive manufacturing. I'll come back to that later. And the armies do too. All of them have a different perspective on additive manufacturing, which is always really interesting because every niche tries to find the perfect use case, as well as automotive and medical. So the average life cycle is in different industries a bit different. We tried to show that on this slide. So automotive, approximately 12 years. After that, a car is not used anymore. From trucks and buses up to planes and shipping. So the longest you can see is rail. At that point, I may also say that I also have a background in rail for 20 years now. And so we have to plan for a very, very, very long time if it comes to spare parts. You will see some of them later on. Here is an example of the Dutch Navy. The Dutch Navy uses as many different shipping companies additive manufacturing for being flexible. Sometimes they have the problem that when they are on sea, and they are on sea for many weeks and months sometimes, and they are not capable of having a spare part which is missing, so they start printing it. And what I really love is the logic of homecomers. So homecomers are used as interim spare parts, and when they come to their harbor, then they replace the spare part again. So it's not really a lightweight case, but still very interesting if it comes to the logic and perspective. This is a beautiful example made by Airbus AppWorks. And yeah, this was published, I guess, 4 years ago. And of course, it was some kind of a study, but that bike already works. And what you can see here is the bionic structure. So you just have material where you really need it, where strengths are forcing that. And so the whole bike is much lighter than before. And I guess you agree, it looks gorgeous. Automotive uses additive manufacturing now for more than 25, 30 years. Usually they use it for prototyping of different parts in cars, and to be much faster in the design period of a car. But now, from time to time, you see more parts which really stay in a serious car. And what you can see here is one of those parts. You can also see the bionic design, and that is used for the roof of that cabrio. A very beautiful part. You can even use it as a design object for your living room. But in fact, it's a braking caliper from a Bugatti, and that is printed from titanium. Therefore, the powderbed technology was used, and it also saves weight. And what is even more interesting, also the assembling. They were able to reduce the parts a lot. So the assembling is less time consuming, less complicated, and therefore also maintenance. As I already said, additive manufacturing used to be the technology for prototypes, or also for concept cars. What is now the case is that the automotive companies, in this case Ford, they use desktop printers to print jigs and fixtures, which is really interesting because they are very flexible. Those printers are not very expensive. And also here, lightweight plays a role, which you can see on the next slide. Here you can see that the part has a different structure. You just have material where it's really needed. So the whole part was weight reduced by approximately 50%. And that is really a great advantage for the workers in the assembling, because they don't have to carry that heavy parts anymore, which really saves also and helps with the staying healthy in the production. That is made possible by additive manufacturing, an example of printing service bureau, the biggest one in Europe, materialized coming from Belgium. But there are different kinds of mobility, and one is definitely the human one. What you can see here is an implant printed in the powderbed technology made from titanium, and that is now quite common. So many implants, knees, even elbows, hips are printed. And why do they do that? First of all, you can do a patient customized implant. And furthermore, as I explained before, the surfaces of those parts are quite rough. And that is a huge advantage in medical because of the roughness of the surfaces. It can be integrated much better, so the bone can grow and integrate in that printed part. So the part is better accepted by the body. Yeah, you might have had some classmates which have the nuisance to have to look like that. So braces to strengthen the teeth used to look like that. With additive manufacturing, they now look like that. So they were able, it's a company coming from Bremen in Germany, to integrate this into the mouth, which really looks much better. So it's not a nuisance anymore. So you see there are many, many different kinds where additive manufacturing can be used. And here you can see even more. So those are different use cases in medical. Often they are used coming from the lower complexity for spare parts for machines like rays and other things. Then it's also used as very simple, easy to print parts in regions where it's hard to get any parts at all. So like Africa or also refugee camps. You can see implants for the body, for the head, and many surgeons also use additive manufacturing for printing models before a very complicated, for instance, heart or cancer surgery to be optimal prepared. How is the tumor located and how to cope with that. Then you can see orthesis, prothesis, and that looks a bit cyborg like, but it's really a great advantage for people who have lost a leg or an arm, because now those are really printed individually for those people and can also replace quite easily. So up to printing medical medicine, that is really interesting because you can integrate also functions when you print pills. So the absorption is different, and that's really interesting in medicine. And what you can see at the very end is a little printed heart, which even worked. That is an example coming from Israel. Very interesting case. So the bioprinting is absolutely increasing, and also in Berlin, for instance, organs are printed and not to be implanted in the first step, but to be used for trials of medical surgeries and also medicine, for instance. So you don't need that many tests of animals. Coming to the rail tries to be more in time with using additive manufacturing. So it's a bit, as I said, a different use case. And that means we need big parts, we need ideally an equivalent to welded parts. We need very cost-efficient production and also always the approval of those parts. So what you can see here, that has nothing to do with lightweight, but I wanted to show it to you because we are really proud of that part. That's a part made of 27 kilograms of stainless steel used for a high-speed train, which goes 350 kilometers an hour. So that's a safety relevant part. And that part was missing. And the 35 million euro expensive train had a standstill of, I guess, 9 months. And the colleagues from the procurement department asked for help, and they couldn't get the part in the markets anymore. So that was the perfect situation for additive manufacturing, and therefore you can see it also on the next slides, we used the DED. But of course, since this is a safety relevant part, we had to take a very close look that everything is fine, that the quality levels and the density levels are fulfilled for this part. And here you can see a little movie from a test stand, how we test those parts, that you have an idea, because that part prevents the train from getting too much into the curves. So of course that has to be tested with a very, very high test frequency. And we had a load change which corresponds to 30 years of operation. But we just needed the part for 7 more years of operation. So now we are absolutely sure that that part will meet the quality levels. But you can also use additive manufacturing for smaller parts. And I love those words in rail. It's window wiper water tank cover. For instance, just one part of a component, and that was missing. But since the window wipers are crucial for rail, because they also have to be able to go on site and to see where they are going, that is really also a very relevant part. And now we don't have to exchange the whole water tank anymore. We just can print the tank cover and everything's fine. Usually, if it comes to rail, we are looking for a one-to-one exchange. So a one-to-one replacement of parts, we can't get it anymore at the market. So usually we are looking for those parts because then form, fit, function is identical, and it's easy to get, quite easy to get the certification. If we have bigger changes, like you can see in the middle, non-extensive changes, then we have to bring a notification. If we have extensive changes, for instance, also totally change the design, do a bionic design, for instance, I've shown you some examples from other sectors, then we have like the approvals for an initial operation approval, which is quite time consuming and also expensive. This is why in rail we mainly stick with the replacement, but that is now also changing. So the first companies in Europe, like the Dutch colleagues, are now thinking about how to integrate additive manufacturing in the procurement process at the very beginning of the life cycle, and not just at the end, what we mainly used to do. And now it's really getting very interesting, because now we can also save weight in rail. This is just a tiny example what you can do. So coming from right to left, this part, it's a holder for a regional train, was weight optimized by Siemens. And here you can also see how it looks, what it looks like afterwards. And so they were able to save 70% of the weight. Even if it doesn't look like that, that's also a very beautiful example. It's a palm tree handle, so-called because it looks like a palm tree, from a metro in Riyadh. And that was also printed and weight reduced, also by approximately 70%, which is really attractive, because then you save weight for the operation and emissions and so on. But furthermore, you also save material, which is very attractive in the powderbed fusion technologies. And that's an example for that, because then you don't have to melt that much material. So the whole production is much cheaper and also faster. That's another beautiful example. It's a sand stair, and that is used for braking in rail. And if you click another time, then you can see what the part, where it is and where it's located. And that was also optimized, and it's lighter now, not because that was necessary for the operation, but as I just said, for the printing process. And then it's becoming cheaper because that is printed from titanium powder. It has a very complex inner structure, which you can't see here, of course, but that was also a very beautiful example which prevented the standstill of cargo locomotives. And here's just a short summary where additive manufacturing can make sense. You have a higher availability of parts. You can substitute just parts of components. You have a solution for your obsolescence problems at the end of the life cycle. You can do functional integration, so functions which couldn't be integrated before, now it's possible. And you can even produce from lot size 1 on, which is really attractive, small numbers, parts you can't get anymore, and now you're so flexible and can reproduce those. Savings in manufacturing costs can be achieved too. That is an example of handrail signs for blinded people. And you can create individual solutions like specific holders, in that case for inlet valves, for instance, designed by colleagues in the maintenance. And of course, for lightweight, bionic design potentials are huge. And that is really a very interesting approach where you can save weight, you can save material. So that means that's also a very green technology. If you take a look into the future, what's the next big thing? And now we are already busy with taking, looking into the future. And what is it? It's the printing with, next slide please, concrete. And that is really interesting because now you can have very flexible structures. In that case, it's stairways for the Dutch railways. And usually you need a lot of formwork for printing stairs. That is not necessary anymore. So you save a lot of material and time and costs. So in the next 2.5 years, we will see a lot of changes. How do you get started if you want to start with that technology? We founded a network which is called MGA, which stands for Mobility and Medical Goes Additive. And what you can see here are all those users coming from different countries throughout Europe. You have all the big printing service bureaus. You have a lot of universities and consultancies which already work with the technology. Then you have the material providers. You have the software companies, which is definitely crucial because you need, before a CAD design and also for the optimization, you need brilliant software. And you have a lot of machining producers for different technologies, different sizes, different materials. So we founded MGA 3 years ago with 9 founding partners, and now we are 120. And what we take care of are exactly those subjects which one company can't solve on its own. For instance, approval. If you do this in a joint approach and address the authorities together with suppliers, OEMs, and operators, that is brilliant and saves also a lot of costs. Same as education, if you want to integrate that into your company, of course, you need to know, how can I educate? How can I train my employees? What can I do? And also, the ecological sustainability is really essential. And as I already mentioned, that is a great case for additive manufacturing. So if you want to know how to start with additive manufacturing, we brought together the experiences of many of our member companies, and that was in our change management booklet, which you can even get via Amazon, and which helps you to get faster and to implement this much faster. Within those working groups, we take care of materials, of use cases, of approval. That, for instance, is the structure of our medical working groups. And next slide. Of course, we always have to take care of also setting standards, because I'm always asked, how do you cope with the approval of those safety relevant spare parts, especially in rail, but also in medical? And of course, you need to prove that form, fit, function is the same, or meets the quality levels and norms. And therefore, we tried to set a standard in cooperation with the TÜV Süd. And you have a lot of printing service bureaus which are already approved by that now. What are our next goals within the network? We try to establish an industrial additive manufacturing hub here in Berlin. And many companies come to Berlin and try to inform or get informed about potential technologies, use cases, and so on. And many company leaders come to me and say, now I've understood that additive manufacturing is the future technology. I want to buy a machine, and which one should I buy? And usually we say, before you buy a machine, and we are talking about costs in the industrial part of the technology of at least 500,000 euros. You have to take a closer look at what do you want to do with that? What are the main use cases? What technology is suitable for that? And therefore, we want to give the room also for companies which would like to come together and talk about those use cases. We've learned a lot from other companies because the aviation industry, for instance, had a lot of experience, and we really took a lot of advantage out of that, the knowledge exchange. And therefore, we also have annual meeting for our members that will take place in person, hopefully in October in Berlin. And next slide. Here you can see the members, and if you want to be a part of that, we would love to welcome you, and yeah, please contact me. So next slide, here you can see my contacts, and thank you very much for your attention.